Okay, so solving algebraically, substitution is just one of the two methods that we're going to be discussing. We're going to focus on substitution today and Monday, and then we'll focus on the other process of solving algebraically, which is called elimination. And then what I'm teaching you guys is when it's best to use substitution versus using elimination. So the way that your system is set up is going to basically indicate to you whether you want to go with the substitution route because it will be faster, or if you want to go with the elimination route because that would be faster. So what I've posed up here are two number statements. The first number statement says 4 times 5 is equal to 20. Is that true? Yes, 4 times 5 does equal 20. What about 23 minus 3? Does that equal 20? Yes. So in this situation, this 4 times 5, if I rewrite that, it's exactly the same thing as that 23 minus 3. So I can actually say that they're equal to each other. I can state that they are equal to each other because they're the same exact value. They both equal 20. So there's many different ways that you can work a problem out to solve for the exact same value. So it's the same thing then when you're dealing with your systems, except you're not just dealing with numbers, you actually have variables involved. So in a situation like problem number 1, I've got y is equal to x minus 3, but I also have that y is equal to 2x. So these are two different ways to be able to solve for the same value. Y is a value, we just don't know what the value is. But if I take x and I subtract 3, that's going to be one way to solve for y. If I take x and I multiply it by 2, that's another way to be able to solve for y. And since I know that y is equal to y, I know that that's a true statement. Y is the same thing as y, then that means that the x minus 3 is also the same thing as the 2x. So what I'm going to do is I'm going to set this up in terms of just my x values. This is my first step. I'm going to set it up as x minus 3 is equal to the 2x. X minus 3 is equal to the 2x. Now, the first thing I want to do is I want to focus on getting my x over to just one side. Now, remember, when we learned how to solve with equations and we had variables on both sides, we always focused on moving the smaller variable. The reason we did that is because it helped us eliminate having to deal with negatives with the variable. So I'm going to write that off to the side. I want to move the smaller variable, or the smaller x term, by addition or subtraction. I'm going to use my addition or my subtraction in order to be able to move my smaller x term. And my smaller x term happens to be the x that's independent. What coefficient is in front of that x? In front of this x? A 1. There's a 1 in front of it, so I know I need to subtract 1x from both sides of my equation. I'm going to subtract a 1x from both sides of my equation. And what that's going to leave me with here is a negative 3. That's going to come down as a negative 3, and I'm going to bring that down in pink. And then 2x minus 1x is just 1x, or x. So I get negative 3 is equal to x, or x is equal to negative 3. So I've just solved for my x. That's my very first step. Now, my second step, my second part of the process, and I'll draw a little wall, is I'm going to use substitution. So remember we talked about substitution? We've done substitution two different ways. The first thing we did is we substituted our y values with our x algebraic expression and solved for x. Now we're going to take that x value and we're going to substitute it back into one of these equations. It does not matter which equation, you just pick one of them. So we're going to substitute the x equals -3 into one of the equations. And again, it does not matter which equation we choose as long as it's an original equation. So I'm going to go ahead and just go with the first one. I'm going to go with y is equal to x minus 3. And I'm going to replace the x again with a -3 because that's what we solved x to equal. So now we've got -3 minus 3. What's -3 minus 3? -6. So we now have y is equal to -6. Now what's really important though is that we don't want to stop here. We want to keep going. And what I mean by keep going is that we're going to check. Because that's the lovely thing about this unit, guys, is you can check to see that you've got the correct solution by substituting both your x and y values into the other equation that you did not use. So I'm going to check it with that second equation. I substituted it into the first. Now I'm going to check both values in the second equation to make sure that it comes out with a true statement. So checking is our last process here. We've got the equation y is equal to 2x. I'm going to replace the y with my -6. And I'm going to replace the x with my -3. Okay, so what's 2 times -3? -6. And so if I get that -6 is equal to -6, that is a true statement, then that means I have my solution now. My final solution that works for both equations, both parts of the system, is -3 for my x value and a -6 for my y value. And there's my solution. So that's what I mean by graphing isn't necessarily a longer method. It's probably faster to graph, but algebraically speaking, it's the more accurate method because it will be able to give you fraction values and decimal values. And if you don't have graph paper available, then algebraic is the way that you want to go. Okay? Now, let's take a look at problem number 2. Problem number 2 is a lot simpler because, yeah, we have y is equal to x plus 4, but we also have y is equal to 2. Who remembers what kind of slope is it when y is equal to number? Is it a zero slope or an undefined slope? Which kind is it? What do you think, Divya? Zero slope. When you have y equaling just a number, that gives you the zero slope because it means at every value of y equaling 2, x is spanning or running along. So it's that horizontal line. Remember, if it was an undefined slope, it would be x equals just a simple number. But here, this is a zero slope. Y is equal to 2. We don't have to solve for y because we're already told what y is equal to. So this is a simpler problem. We can just take that value of y and substitute it in for x, and then we're done. We'll have our solution. So we're going to take this value of y, and we're going to substitute it. So our original equation that we need to substitute it into is that y is equal to x plus 4. We're going to replace the y value with a positive 2. So we get 2 is equal to x plus 4, and then we're going to solve. So the only thing that we can do in this situation is to subtract 4. So we'll subtract 4 from both sides. These 4's are going to be what cancels out. And then 2 minus 4 is a -2. So we get -2 is equal to x. There isn't anything that we can do to check because there was only one equation that we were able to substitute into. So that gives you your final solution. Your solution, and you just have to make sure you put them in the correct order. Remember, x always goes first. So I'm going to write that above here that this is your x value. X always gets written first, -2. your y value always gets written second, which is a positive 2. And did you guys actually know that there is such thing as a z-coordinate as well? You did? Awesome. Where did you learn about that? Minecraft. There is such thing as a z-coordinate. So you guys know x and y, when you plot it, it's on a 2-dimensional plane, but you actually have a z-coordinate that comes out to make it a 3-dimensional plane. You'll focus on that when you guys get into calculus. Specifically Calc 3 for those of you who are going into a STEM job. So if you're going into any kind of technology or science or, you know, mathematical field, computer coding, anything of that sort, that would be you taking Calc 3. So it's pretty interesting stuff. All right. Problem 3, I'm going to do one more example with you guys, and then I'm going to have you branch off and do 3 examples or 4 examples. No, 3 examples. We'll do 3 examples on your own. Let's take a look here. We have y is equal to x minus 6, and we have y is equal to 3x. Again, that concept of y is equal to y, they're both written in y equals format. So that means we can take these 2 different portions here. I can take this x minus the 6, and I can take this 3x, and I can set them equal to each other because they both are equal to the value y. So we're going to start off with this step first. I'm going to put x minus 6 is equal to 3x. X minus 6 is equal to 3x. Now, I need to get x over to just one side of my equation. Which one do I want to move? Do I want to move x or 3x? X. Always focus on moving the smaller one. It's a lot easier. So I'm going to put a box around my x. What coefficient is in front of it? 1. So what operation are we going to do? Add it or subtract it? Subtraction. We're going to subtract 1x from both sides. Okay. Now, when I do so, what am I left with over here? I'm left with 6 equals negative. That minus sign has to come down. Please don't forget that. Negative 6 is equal to what? 2x. Okay, and then from here, what do I need to do to solve? And what are we dividing by? 2. We're going to divide both sides by a positive 2, and we'll get x isolated because those 2's will simplify to a value of 1. Okay, so negative 6 divided by 2 comes out to negative 3. So we get negative 3 is equal to x, or if you prefer to write it as x equals negative 3, that's what I like to do. So I'm going to circle that. Okay, once I found out my value of x, what do I need to do next? What's my next step? Alex? Substitute. Does it matter which one I pick? No. I typically like to go ahead and just go with the first one. Just a thing. So we're going to substitute. We're going to substitute x equaling negative 3 into my first equation. I'm going to pick y is equal to x minus 6. So I'm going to replace the x with a negative 3. So I now have y is equal to negative 3 minus 6. And what is negative 3 minus 6? Negative 9. So we get negative 9 for my y. Okay, what's the last thing that I should always do? Say it louder. Check. We should check. And which equation are we going to use to check it with? Am I going to plug it into this one? Why not? Because I already used it. So which one I have to use is the second one. I need to use the second one. So we have y is equal to 3 times x. What am I replacing the y with? Negative 9. Be careful, if you replace the wrong thing, you're going to wind up seeing, oh, it looks wrong, it doesn't work, when really you just substituted the wrong value. What are we replacing the x with? Negative 3. And what's 3 times negative 3? Negative 9. So we get negative 9 is equal to negative 9. It's true, it worked. We have our solution. So our solution in the correct order, our x value, comma, our y value. X value is negative 3. Y value is negative 9. All right, I want you guys to try problems 4, 5, and 6 on the back. 4, 5, and 6, it's on the back of your page. I'll leave this up here in case you need to check it again. Okay, let's go ahead and go over the answers. For problem number 4, you should have gotten your answer to be 5, 20. So 5 for your x value, 20 for your y value. For problem number 5, you should have gotten 3, negative 1. 3 for your x, negative 1 for your y. And then for problem number 6, you should have gotten negative 1, 5. Negative 1 for your x and 5 for your y. Anybody need me to go over one of these? Everybody's okay with how they got them? Okay, so let's go ahead and go to the next page then. On the next page, I have examples 7 and 8, and I wanted to do these ones with you because, as you probably know, you're going to come across situations where you're not always going to have a solution. What are the other types of solutions that you could have? Give me another name for another solution. These were all one solutions. What's another solution type that we could have, Bridget? Infinitely many. And what's in the third solution that we could possibly have, Alex? No solution whatsoever. Okay, so number 7 is an example of infinitely many solutions. Let me show you why. If you look at y is equal to negative 13 plus 3x and y is equal to 3x minus 13, if we go ahead and set these equal to each other, so if we take negative 13 plus 3x and 3x minus the 13 and set them equal to each other, we're going to notice that the x's are going to disappear, and what we're left with is a value that is set equal to each other on both sides. So if I were to go ahead and subtract 3x from both sides, not only is my 3x going to cancel on the left, but it's also going to cancel on the right, and then I'm left with the statement of negative 13 is equal to negative 13. So when your x's completely disappear, but you're left with a true statement, then that means it's infinitely many solutions. I'm just going to put infinitely many. That means every value of x and every value of y is going to work. Every value of x and y will work for that situation. And it makes sense because if we look at these are actually identical equations. They're just written in a different format. Negative 13 plus 3x can also be written as 3x minus 13. Okay? Now if we look at problem number 8, this is an example of no solution, which should make sense because remember we talked about that yesterday, that if it's no solution, you'll have identical slopes, but you will have different y-intercepts. Your slopes are exactly the same, but your y-intercepts are different, which creates that parallel line because you're graphing them at y-intercepts, and then you're following the same pattern of graphing for each additional point. But if you were to look at it algebraically, and I set this up to each other, 2x minus 4 is going to be equal to 2x plus 7. Again, those x's would cancel out. If I subtract 2x from both sides, these x's will wind up canceling out, and what I'm left with is the statement negative 4 is equal to a positive 7. And that is a false statement. When you get a false statement, then we know that the solution is no solution. Okay, so no value is going to work. Okay. Now, all of the problems that I've shown you happen to be where they're all written in y equals format, right? Both equations were written as y equals. But what happens if you are in a situation where only one of them is written in slope-intercept form? Both of them are not written in that slope-intercept form. You can still solve using substitution. Substitution is still an easiest method to use. You would just, I don't want to say rewrite the equations because as long as one of them is written in y equals mx plus b or x equals my plus b. It's okay if x is the one that's isolated as well. You can still do the substitution. As long as one of them is written in that format, substitution is still the best method. If neither one of them is written in that format, then that's when we would use elimination. But for all intents and purposes, you would want one of them written in this format for substitution. The next thing you would then do is you would substitute your isolated expression in place of the variable with your alternate equation. I know that doesn't sound like it makes any sense. It will when you see it in the process. The third step is to solve your equation for the remaining variable. So that means it should equal a number. You should get y equals a number or x equals a number. And then you would take that value and just follow the same process that we've done before. Substitute it back into an original equation and solve for the other missing variable. And then, as always, check, check, check. Okay? So let's take a look using these steps. Here, we've got negative 8x minus y is equal to negative 14. That's not in slope-intercept form. But we do have y is equal to negative 2x plus 2. That is written in slope-intercept form. So the fact that we still have one of them in slope-intercept form is good. What we want to do is we're going to take, so what I said up here, you're substituting the isolated expression. This right here is called an isolated expression. Okay? Y is equal. Your y is isolated, and this is the expression that isolated value is equal to. You're going to take this entire expression and you're going to substitute it into the y. You're taking this entire expression and you're substituting it in to this y because y equals this expression. Does that make sense to you guys? Okay, I know y is equal to negative 2x plus 2, so over here where it says y, I'm going to plug in negative 2x plus 2. So I'm going to rewrite that entire thing. I still have this negative 8x. I still have this minus sign, but I'm now going to have my new expression of negative 2x plus 2, and the whole thing is equal to negative 14. So now when I go about solving it, I need to solve it using my rules. I have to do my distributive property first because there is a negative 1 written right here outside of that parentheses. So I'm going to distribute a negative 1 to each component here. Negative 1 times negative 2x, that's what I need to do first, is going to come out to a positive 2x. Then a negative 1 times a positive 2 is going to come out to a negative 2. So I still have this negative 8x, and on the other side I still have equals negative 14. Now I can combine my like terms. My like terms that I can combine are right here, negative 8x plus 2x. What's negative 8x plus 2x? Negative 6x. Good. So we have negative 6x. We still have this minus 2 is equal to negative 14. Okay. Then we add 2 to both sides. That gives us negative 6x is now equal to negative 12. We then divide both sides by negative 6, and we've got x isolated. X is equal to a positive 2. Okay? What do we do now that we have x is equal to 2? Substitute. Okay, now pick one of the values. Which one do you think is easier for me to substitute into if I'm trying to solve for y? The first one or the second one? Second one, because y is already by itself, isn't it? It says y equals. So why not just substitute it into there? Substitute it into the one that says y equals. It's a lot easier. So it's y equals negative 2x plus 2. I'm going to replace the x with that positive 2. So I now have y is equal to negative 2 times positive 2 plus 2. Negative 2 times 2 is a negative 4, and negative 4 plus 2 is a negative 2. So we get y is equal to negative 2. And then the last thing to do is to check it. We're going to use the other equation. Negative 8x minus y is equal to negative 14. So I'm going to do negative 8 times my x value, which is a positive 2, minus my y value, which was a negative 2. Ooh, I can't. Sorry, I didn't realize I wasn't showing you that side. And then the whole thing is equal to a negative 14. Bless you. It's like demons coming out of you right now. Okay, negative 8 times 2 is a negative 16. Minus a negative 2. Now, do we like to do double negatives? No, what's a double negative really? Positive, so it's plus 2. And negative 16 plus 2 is negative 14. So it did work. Okay, so here's our solution. It's a little bit longer of a process, but there it is. Our solution is 2, negative 2. Okay. A little bit longer, but it's still there. We're going to do one more example, and then I want you to be able to get onto your work, okay? I know I have 4 examples total, but I want to just do one more so you can get onto your assignment. Does anybody still need this? Okay, so go ahead and flip it on over to the back. Let's take a look at problem number 2. I'll post the solutions, or I'll continue videoing showing how to work out problem 3 and 4 while you work, and then if you want to see them later, you can either watch as I'm doing it, or you can get on and watch it tonight. All right, so let's take a look at problem number 2. 5y minus 5x is equal to 0. X is equal to 8y. This is our isolated expression. We have x is equal, so this one's different. It's not y anymore, it's x. X is equal. So I'm going to take this value, this 8y, and I'm going to substitute it in for where I see the x. I'm going to replace the x on this equation with the term 8y. So I have 5y minus 5 times 8y, and the whole thing is equal to 0. Okay, the first thing that I need to do is I need to distribute. I need to take this negative 5 and I'm going to distribute it to the 8y. What's negative 5 times 8y? Negative 40y. Okay, so we get negative 40y here. So that means we have 5y minus 40y is equal to 0. What's 5y minus 40y? Negative 35y. So we have negative 35y is equal to 0. My last step is to just divide both sides by negative 35. And what is 0 divided by negative 35? 0. So y is equal to 0. Okay, now we're going to substitute it in. I'm going to substitute in so I can solve for x, and the one that I'm going to substitute it in is where x is already isolated. So I'm going to substitute x equals 8y. I'm going to replace the y with 0, because that's what I just solved y for. And what's 8 times 0? 0. So I get x is equal to 0. And now I just need to check. So we're going to take 5y minus 5x is equal to 0. And we're going to plug all those zeros in. Okay, replacing the y with a 0. Replacing the x with a 0. What's 5 times 0? 0. And 0 minus 0 is 0. So then there's our solution. Our solution is 0, 0. Very easy. Okay, you can log on to your computer, go on to Delta Math. The assignment is loaded in. Go to Delta Math. Don't go to Google Classroom. It's not loaded at Google Classroom yet. It's on Delta Math. So log into Delta Math. You should be able to see the assignment. Yeah. Yeah. Okay, while you're working, I'm going to go ahead and do problem 3 and 4 up here. If you wanted to follow along, you're perfectly fine to do so. Oops. I've substituted into the wrong thing. Huh. Ms. French-Zheng made a mistake. Actually, here, we'll just cross this off. Go to the next one. My bad.